This is the ALEKS help video for 2.6 through 2.9. You can look here. We want to give a pair of corresponding angles, a pair of alternate exterior angles, and a pair of alternate interior angles. Just as a quick reminder here, I will do an example of each on these lines here. When you have a transversal, corresponding angles would be one in, one out, same side. One in, one out, same side. So an example here would be like 3 and 7. Alternate exterior angles, opposite sides of the stir stick outside the line. So an example here would be 2 and 8. And alternate interior angles, also known as armpits of the Z, would be like between the lines, opposite sides of the stir stick, and that would be like 4 and 6. In the figure below, the measure angle ABD is 88. Measure angle CBD is 56. BE bisects CBD. Find ABE. So we label everything. Angle ABD, A, B, D, trace and sweep is 88. CBD, C, B, D, trace and sweep is 56. BE bisects CBD, so BE cuts the green angle in half. So this is true. And our goal is to find ABE. ABE. This pizza slice is our goal. So don't just focus on what you're told to focus on. Just ask yourself, what's true? Well, 56 being cut in half, then I know that's going to be 28 and 28. I'm like, well, what else is true? I could find this orange pizza slice because I have the blue 88 and I have the green 56. So I find that orange pizza slice from here to here is going to be 32. And you ask yourself, do I have enough information to get this whole slice? And the answer is yes. It's 32 and 28. Whoop, 28. I wrote down 88. Let's do that again. So 32 and 28. And the answer would be 60 there. Says in the figure below, M is parallel to N. So I'm going to color code that. These are parallel. And P is parallel to Q. So we're parallel going both ways. Most important thing when you got parallel lines is remember what those properties are. And most important ones you need to watch out for is armpits of the Z, known as alternate interior angle, is angle equals angle. Also watch out for corresponding ones in, ones out, same side. When lines are parallel, that's also angle equals angle. Watch out for vertical angles, cat whisker angles. That's also angle equals angle. Also watch out for linear pairs, share a spine, make a line, which adds up to 180. Finally, you need same side of the stir stick between the lines. That's same side interior, consecutive interior adds up to 180 as well. Knowing that, we go through here. You start with the one angle that has a measurement, which is 62, and Z. That matches right there, same side interior, which means they add up to 180. So I'm simply going to do 62, 180. That's 118. Then I take a look here and I've got, if that's 118, it's going to walk it down. This is also 118. And I could do armpits of the Z. which means that's 118. It's also corresponding. So now I could do this math. 4y minus 2 equals 118. 4y equals 120. Or 4y would equal 30. So keep that chart close by in your reference booklet. Use the given information to prove that x is parallel to y. Well, in this case, let's see what we got here. We want to prove we are told that 8 and 1 are parallel. Not parallel, congruent. Now, we know that if alternate exterior angles are congruent, then the lines are parallel. That's what those are. So the proof here would literally only be 2 steps. Okay, you would have statements, reason. Okay, we start with this. Step number 1, you would write the given. Angle 8 is congruent to angle 1. And the reason why? It is given. And we're told they're congruent, which means, therefore, these lines are automatically parallel. So x parallel to y. And the reason you're looking for is if alternate exterior angles are congruent, comma, then you have parallel lines. This is from lesson 2.8. Says right here, the equations of the 3 lines are given below. You're going to need the slope of each equation. So this first one is already in y equals mx plus b form. So your slope here is -2. There's nothing to do there. Your slope here is -2. This, however, is not in y equals mx plus b. So your first order of business is to get it in y equals mx plus b form. So your new equation is going to be y equals, double negative makes a positive, 1/2 x minus 1. Now we have found our slope there. Now, remember the rule is this. If lines are parallel, the slope equals the slope. If lines are perpendicular, slope times slope equals -1. In other words, they are opposite reciprocals. Let me color code that for you. That would be like this. Okay, if I have something that looks like this, red over blue, and it's positive, its opposite reciprocal would be blue over red, and then it would be negative. So you're looking for opposite reciprocals for perpendicular lines. You're looking for congruency for parallel lines. So lines 1 and 2, take a look here. Line 1, line 2, they're exactly the same. Therefore, they are parallel. Line 1 and 3, here's line 1 and line 3. That is -2 over 1 times 1 over 2. That does equal -1. So that means they're perpendicular. Last, line 2 and 3. Again, that's -2 times 1 over 2, and that is going to be perpendicular. Says the equation of a line that is perpendicular to x equals -5 and passes through this point, right? Undefined if necessary. So your first order of business is to graph this line, x equals -5. That's all the points where x is -5, comma, something. So just start graphing a bunch of points. So -5, 0, -5, 1, -5, 2, and you see that x equals -5 is a completely vertical line. And the slope is undefined. Zero slope, undefined. Zero slope, undefined. Zero slope, undefined. Zero slope, undefined. Do that like 6 times. Zero slope, undefined. So the slope here is undefined. All right. Now we want a line that's perpendicular to this. So right off the bat, we know it has to go horizontally, but goes through this point, -8, -5, -8, -5. So if I graph a line that goes through this point and is perpendicular, we know it has to be horizontal. And all horizontal lines are y equals lines. So y equals, really simple, -5. So my equation is y equals -5. And my slope that's perpendicular would be undefined. No, not perpendicular. The original slope was undefined. Therefore, the perpendicular slope is 0 slope. The original is with undefined. And perpendicular slope is 0. Last one. Consider the line -3x plus 7y equals 5. Find the equation of a line. When it says equation of a line, it wants it in this form. Y equals mx plus b. That is parallel to this line. When it says this line, it means this original line, but passes through that point. Now, parallel, keep in mind, parallel means slope is equal to slope. And your second one, find the equation of a line and goes through that point. That is perpendicular to this line, and that is slope times slope equals -1. Okay, so first order of business is to get this in y equals mx plus b form. So we have -3x plus 7y equals 5. Okay, don't panic with the fraction there. Y equals 3/7x plus 5/7. At the moment, I'm not going to ask you to graph it. All you really need is the slope. All right, now we're going to do 2 versions here. We're going to do the parallel version, and we're going to do the perpendicular version. All right, so I'm going to go 2 versions here. I'm going to put parallel on the left. What color do I have parallel? It's blue. I'm going to do parallel on the left, perpendicular on the right. All right. So one step at a time here. So you're going to be fine. I know you're kind of scared with a little fraction. It's going to be fine. So we're going to write y equals mx plus b. Y equals mx plus b. Let's do parallel first. Parallel. My slope has to be exactly the same because slope equals slope. So my parallel slope is 3/7. My perpendicular slope, slope times slope equals -1. It's the flip and switch. So it's -7/3. Keep that in mind. Those are your slopes. Those are going to be your m's. Now, ready? We are told for the parallel that -3 is your x. So I'm going to put -3 right here. 4 is your y. There's a 4 equals. My slope I'm going to use is 3/7. Parentheses around that. That's times plus b. Leave that alone for a second. We'll come back and solve it in a minute. Over here, same thing. Our y is 4. Our slope here is -7/3 times our x, which is -3 plus b. Okay, we're going to solve for both. And over here, I have 4 equals 3 times 3. That's going to be -9/7 plus b. Now, a lot of you are a little freaked out about the fraction, but remember, there's a way we could kiss fractions goodbye, and that is arrow in, arrow out. So step 1, we make everything a fraction. So I pop that over 1, pop that over 1. Step 2, I do arrow in, arrow out. Oh, nope, that's not step 2, that's step 3. Step 2, you find the lowest common denominator. And I have a 1, a 7, and a 1, so my LCD here is going to simply be 7. Now, step 3, arrow in, arrow out. This goes all the way back to over a month ago. Ready? Watch. 1 goes into 7. 7 times 4. This becomes 28. 7 goes into 7 one time. Little 1 there. That stays -9. Bring down the plus sign. And color have I not used? I haven't used red. 1 goes into 7 times. And that's going to be 7b. Now, goodbye fractions. Now you solve. So b equals 37/7. Your final version, therefore, of parallel is going to look like this. I'm going to bring it over here. And it's going to be y equals 3/7x plus 37/7. That's that version. That's the parallel version. And ALEKS prefers improper fractions. Do not change that to a mixed number. Coming over here, math on this side's a little bit easier. This is 4. That's going to be -3 times -7. It's 21/3 plus b. Lucky you, this is a whole number. 4 equals 7 plus b. And b equals -3. So your perpendicular version of the equation, perpendicular version is going to be y equals -7/3 x minus 3. That's the perpendicular version. If you want to go ahead and graph that, you'll see that everything works together. I'm going to go ahead and graph it so you don't have to graph. I'm just going to show you how it confirms it so that you are comfortable with it. Remember, our original equation is y equals 3/7x plus 5/7. Now, 5/7 is a little less than 1, right? Little less than 1. It looks a little tricky to graph, but we'll do the best we can, and it's 3/7. So this is all just an estimation. So 5/7 is about right here. And it is that original equation? There it is, 3/7. So we kind of bunny hop, 3-ish, 1, 2, 3. This is not an exact, over 7. 1, 2, 3, 4, 5, 6, 7. So that is approximately my original given line. That's your original line. Let's do our parallel line going through our point. Our point is -3, comma, +4. 1, 2, -3, comma, 4. And this parallel line, 7 goes into 37 approximately 5 times with 2 left over. So we start at 5 2/7. And it's going to look really weird to you. 5 2/7, a little, just a little past the 5 here. And remember, it's 3 up, 7 over. So 1, 2, 3-ish. 1, 2, 3, 4, 5, 6, 7. Okay. I don't have a straight edge. This isn't very exact, but you can kind of see where we're going with this. This was the parallel. And you asked, does it go through that point? And looky there, it kind of does. There you go. Perpendicular. Perpendicular is a lot easier to graph because it is just at the -3. And it is going to be down 7/3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And if you graph that, you can see how it fits together and goes through that point. So you can ultimately graph to check. If you do your algebra correctly, you should be fine.